So let's take a look at question 2. Question 2 of extensive challenges. This is pretty much an abstract question. Let's take a look at what it's talking about. So it says that Pip and Jim are playing a game of writing numbers on a blackboard. The rule is that they are taking turns to write a number from 1 to 10, but they are forbidden to write the factors of a number that is already on the board. So the one who is unable to write on the board on his turn will lose the game. If Pip is starting first, who has the winning strategy? Well, at first glance, no one knows how to do this question, right? But then I know that it's about numbers from 1 to 10 and it's about some factors. So first of all, I'm just trying to write down all the numbers from 1 to 10. And then I'm also writing down their factors. Because once I write that number, the factors cannot be included either, right? So that's the reason why I'm trying to write down the factors there. So it might take a while, but you will eventually get there. We can see that now I have 3 numbers with 4 factors, 2 numbers with 3 factors, 4 numbers with 2 factors, and 1 with 1 factor. But then for the 1, we don't really need to care about it because writing any other numbers will forbid me from writing the 1, right? So what we're trying to do here is, like what Pip is trying to do here by writing first, is trying to construct a so-called symmetry such that whatever his opponent does, he can do the exact opposite. Now, the number of factors is what is determining the win or lose of this game, right? So I can use the number of factors of each number to construct a symmetry. Now we can see that I have 3 of 4 factors, 2 of 3 factors, and 4 of 2 factors, with only 1 with 1 factor, right? So if I am just trying to cross out I'm just trying to write down any one of these 3 numbers, such that it becomes 2 of these numbers, then you can see that these are all going to be even numbers, where the last one is going to be cancelled out, right? So this looks pretty ideal, but then crossing out one of these numbers with, writing down one of these numbers with 4 factors is going to affect the others. So we need to see how it works. We need to see how it works after I write it down. So first, if I cancel out 10, it means that 5, 2, 1 are also gone. So 2, 1 are gone, 1 is gone, 1 is gone, 1 is gone, 2 is gone, 1, 2 is gone, 1 is gone, 2, 1 is gone, 1 is gone. So what do we have remaining? We have 3 groups with 3 factors and 3 groups with 2 factors and 3 with 1 factor only. So definitely 3 is not what we so-called symmetrical because it's an odd number. So your opponent can control what you are doing there. So this doesn't satisfy the condition we require to construct a symmetry. Then if I'm crossing out the 8, it means that 4, 2, 1 are gone. So first of all, I can cancel out this 2, 1, 1, 1, 2, 1, 1, 2, 1, 4, 2, 1, 1, 2, 1, 1, right? And what we have remaining will be 3 groups of 2 factors again, and 3 groups of 1 factor again. So again, this doesn't satisfy the condition of being symmetrical. So next, we are trying to move on to 6. If I cross out a 6, it means that 3, 2, and 1 are gone. So 3, 1 is gone, 2, 1 is gone, 1 is gone, 2, 1 is gone, 1 is gone, 1 is gone, 2, 1 is gone, 3, 1 is gone, 2, 1 is gone. And now I have 4, 5, 7, 9, 8, 4, and 10, 5, which does satisfy our requirement for these two sets to be symmetrical. But then we need to choose the symmetrical pairs very carefully, because you can see that if I write down 8, it means that 4 is forbidden. If I write down 10, it means 5 is forbidden, where 4 and 5 are still in the list. So you can say that these two lists are going to be 4, 7, 8 in symmetry with 5, 9, and 10. So the 7 and the 9 can swap between them because they are not determined by any other numbers. But 4 and 8 and 5 and 10 are going to form a pair, which means that if you write down 4, if like Jim writes down 4, Pip can write down 5. If Jim writes down 7, Pip can write down 9. If Jim writes down 8, Pip can write down 10. And the other way around, the same. If Jim writes down 5, Pip writes 4, so on. Okay, so that's how Pip can win this game. So Pip has the winning strategy by writing 4 first. No, writing 6 first. And then construct the symmetry as below. So these two groups are in symmetry. All right, pretty abstract question. So if you're not understanding it, that's totally fine. That's totally fine. Okay, so that's going to be the last question for this lesson. And well, luckily for this whole term as well. So I will see you all in the next term. Bye bye.